Hello, I'm the last speaker. I'm Tom Stahovich. I'm from the University of California, Riverside. And for the last decade and a half, I've been doing work in building natural user interfaces for software. So let me start with a really simple example. So those who are engineers, this laser pointer doesn't work well, recognize that as a couple of masses connected with springs and dampers. It's a nice, simple system. An obvious question to ask would be, what are the natural frequencies of this system? It's a question that an engineer needs to know. So I went to Adams and tried to answer that question. And it took me 4 hours to answer that question. I spent the entire time trying to explain to Adams where the masses were, how they were connected. It's a good program, and I was a novice, so if there's anybody here from Adams. But the issue remains that it took me a long time to convey to the program that simple sketch that I conveyed to you in 10 seconds. I was trying to learn to speak the program's language, but that's not what I want to do. I want software to be able to understand the same sketch that I use when I talk to you. So we set out to build our own tool for this kind of problem. And if we could have the video, please. This is what our tool looks like. You grab a pen, you grab a tablet PC, and you draw the system that you want to analyze. There aren't any special gestures. You simply draw the entire scene just like you would on a sheet of paper. You don't have to pause between characters like you would on a Palm Pilot. And when you're done, there's a menu option that says interpret it. It does, labels the masses, does all the analysis that you'd want to do for free, Bode diagrams, simulation results, directly from your sketch. So you use it just like paper. We want the CAD tool to be just like paper, but we also want it to do stuff that you can't do with paper. All right, if you could switch back to the PowerPoint, please. So, now move forward about 2 years, and I was writing an NSF proposal, and I needed a figure. And I asked a colleague of mine if he could make a 3D model for me for the figure. And I grabbed a sheet of paper, and I drew him that sketch. And I said, this is what I want you to make. And I said, the way that it works is I'm going to push on this piston. It's going to move forward. It's going to push air through that passage. Pressure is going to build up behind this piston. When that pressure is big enough, it overcomes the spring, uncovers that hole, and the air can escape. So it's a thresholding pressure regulator on a manual pump. Go make that for me. The next day I came in and he was really angry at me because he spent 8 hours making that. So the issue is, if I can tell him in 2 minutes with some speech and gestures and a sketch what I want him to make, how come it takes hours to get a CAD modeling tool to do the same thing? So after we had that conversation, I immediately changed the proposal, which was due 2 days later. And the topic of the proposal was, can we build a CAD system that works from speech, sketch, and gesture and generates 3D models from it? And it was a successful proposal. Otherwise, I wouldn't be here. And so we're now working on that. We just started this project, so it's new. We haven't gotten a lot done yet, but we are making some progress. But the goal here is to literally make a system that can work from the kinds of input, kinds of discussions that you'd have with an intelligent colleague. Part of that involves embedding in the system some of the common sense that an intelligent colleague would have. So we're having to build in notions of what springs are and pistons and things like that, build in a vocabulary of common engineering terms. And so the end is that if this works, we will be able to sit down, talk to our computer, draw pictures, point at those pictures, and explain to the system what we'd like. And it should be able to create the models we'd like with some luck. All right. That's my contact information. Thank you.